Good day, dear student. I'm Christine Congo, your tutor for Natural Science and Health 5 for the Bachelor of Education Senior Primary for the year 2021. Welcome to the exam-based conduct classes for Natural Health Science and Health Education 5. Starting with the introduction, the main aim of this presentation is simple to highlight some important aspects of the modules that students require in preparing for the assignments and the examination for the year 2021. I hope you are familiar with the outline, with the course outline, and you know what topics and which content are you supposed to cover for this module. As you know, the content of the module is such long, so we will not be able to cover the whole content as much, but we will rather focus on some topics which seems to be more challenging to the student. However, some of the topics that where students think you don't understand, you should feel free and then you can consult me for some more explanation. Without wasting time, we'll start with one of the topics in our module, mass and weight. According to our module, students are expected to be able to differentiate between mass and weight. Mass and weight can be differentiated in different ways. You can differentiate them by defining mass and defining weight respectively. The definition of mass is provided there. We can also define mass. We can also differentiate between mass and weight by stating the unit for each quantity. Mass is measured in kilograms and weight is measured in newtons. One can also differentiate mass and weight by stating that mass is a scalar quantity and weight is a vector quantity. Maybe just to highlight about difference between a scalar and a vector quantity. A scalar quantity, it's a quantity that has magnitude or size only, while a vector quantity is a quantity that has both size and direction. The next thing that we also need to know about mass and weight, there's a formula that relates mass and weight, and this is given by Newton's second law. It can be written as force is equal to ma, m stands for mass, a stands for acceleration due to gravity, or we can also use the equation that is also given there. W is equal to mg, where W stands for weight, m for mass, g stands for gravitational field strength. So students should be able to use this formula to calculate mass or weight. And students should take note that g is a constant value, that's acceleration, that's gravitational field strength of the object on of the object on Earth, and the value of that g is 10 Newton per kg. The value of g on the moon is also provided there, it's 1.6 Newton per kg. One should be able to use this formula either to calculate mass given the weight or to calculate weight given the mass. Then we proceed to the next topic. The next topic, in your study guide or in other books, you might find that topic is written as moment. In other words, it's called turning effect of force. Moment can be defined as the turning effect of a force about a pivoting point. The moment of force of an object depends on two factors: the force and the distance over which the turning effect is acting. Therefore, from these factors, we can derive the formula for calculating moment of force. Moment of force is equal to force times perpendicular distance. The distance must be perpendicular to the force that should be used to calculate moment. The unit of force is Newton. The distance should be always converted to meter if it is not given in meter. Therefore, the formula, the unit for moment, is Newton meter. Then we move to the next topic. The next topic that we're going to cover is density. Most of the topics and some other quantity that we learn in this module, first we need to know how to define that that terminology. And from the definition of the terminology, one should be able to derive the formula that relates to that terminology, or the formula that can be used to calculate that quantity. Density is defined as the mass per unit volume. From that definition, students should be able to derive the formula that can be used to calculate density given the mass and the volume. And students are encouraged to use the words rather than using the symbols, because sometimes the symbols that they are using are not correct. So it's rather simple to use the word. When you're writing the formula, you are advised to write the words. Density is equal to mass divided by volume. The formula, okay, the symbols are just given for you to be aware of them in case you found them used in a certain books, but to avoid losing marks unnecessarily, use the words. The same formula can also be used to calculate mass given the density and the volume, or to calculate volume given the density and the mass of a substance. There are 2 units for density, depending on what unit is used for mass and volume. So therefore, the SI unit for density is either kilogram per cubic meter or gram per cubic centimeter. Students should note that if the mass is given in kilograms, then the volume must be in cubic meter. If the mass is given in grams, then the volume should be used in cubic centimeter. The smaller volume for smaller volume, and that determines the final volume for the density. Then we proceed to the next topic of our interest, that's center of gravity, abbreviated as CG. It's also called center of mass. Center of mass of an object is a point where the whole weight appears to act on an object. Students are also advised to go through their study guide and other related books to read more on how to determine center of mass on an object. Center of mass or center of gravity of an object will not change regardless of how the object is oriented. The center of gravity can also lie outside of an object. Then you look at the stability of an object, how center of mass affect the stability of an object. First, defining what stability is. Stability of an object is the ability of an object to retain its original position after being displaced slightly. Stability of an object can be improved or can be affected by 2 factors: the position of center of mass and the size of the base area. To increase the stability of an object, the center of mass should be as low as possible. And to increase stability of an object, the base area should be as large as possible. For example, if you compare like normal cars and race cars. Race car has broad tires. Broad tires represent now a base area which is broad enough to make them more stable, and they are lower closer to the ground to lower their position of center of mass, and that's what makes them to be more stable because they are being driven at high speed. Then we move to the next topic, that's pressure. The definition of pressure is given there as the force acting per unit area. From this definition, one can also derive the formula for calculating pressure, or the formula that relates pressure to area and force. Apart from that, students are also expected to know the relationship between pressure and area as well as between pressure and force. Right? For example, if you increase the area, what happened to the pressure? Or if you increase the force, what happened to the pressure? The relationship between pressure and area is that the relationship is inversely proportional. If the area is bigger, then the pressure is less. If the area is smaller, then the pressure is greater. So pressure is it's inversely proportional to area. In the relationship between pressure and force, it's that if you increase the force, you increase the pressure, So pressure is direct proportional to force. To calculate pressure, area can be either in meter squared or in centimeter squared. Force should be always in Newton. That's the only unit we know for force. And therefore the SI unit for pressure is Pascal, whereby 1 Pascal is equal to 1 Newton per meter squared. That was pressure in solids. Then we move to pressure in liquids. An object immersed in a uniform liquid will experience a pressure which depends only on the height of the liquid above the object. This means that pressure in liquids depends on 3 factors, which is the density of the liquid, the height of the liquid, and the gravitational force or the gravitational pull of the earth on that object. Therefore, the diagram that we have on the slide there, P stands for pressure, then we have 0, P1, P0, P1, P2, and P3. This is indicating now the pressure at level 0, at pressure at level 1 and 2 and 3. So pressure at P0, it's the least one, and pressure at P3, it's the greatest. So pressure in liquid increases with the increase in the depth or in the height. Therefore, from this, we can also derive the formula for calculating pressure in liquids. Students should take note that there is a formula for calculating pressure in solid. For example, the pressure that we exert on the ground when you are standing, that one is calculated by dividing the force by area by force. Pardon me. If you are to calculate or to determine the pressure that we exert on the ground when you are standing there, so we use the formula pressure is force divided by area. If we are to determine the pressure in liquids, there is a different formula which is given there. Again, this is given in using symbols. Pressure is equal to, the first symbol, it looks like a P, but it's not supposed to be a P. It's a symbol that represents density. Otherwise, in words, one can write it as pressure is equal to density times G. G is gravitational field strength, which is a constant equal to 10 Newton per kg. H represents the height or the depth of the container in which the liquid is. Then we also need to take note when it comes to the unit of the quantity that you're using when you're calculating pressure in liquid. We know density, the unit can be either kilogram per cubic meter. The unit for G is constant always, it's Newton per kg. And then the height should be in meter. If the density is in gram per cubic centimeter, then the height should be in centimeter. But the more preferable way of calculating it is density should be in kilogram per cubic meter, and height should be in meter because the value of G doesn't change. Then we move to gas pressure, sometimes referred as atmospheric pressure. This is the pressure that is exerted by gas particles on the wall of a container. Gas pressure depends on several factors. It depends on the amount of mass. It also depends on the size of the particles. It also depends on the temperature inside the container. The larger number of molecules move at high speed, colliding against the container's wall and exerting force against the wall when they bounce off the wall. That's how gas particles cause pressure on the container where they are. Force per unit area exerted by the molecule on the wall is the pressure of the gas on the wall. Gas pressure increases when the number of molecules in the container increases, as well as when the speed of the molecules increases. Molecules have large masses, tends also to increase gas pressure. Then you also need to know that if you want to increase gas pressure, you simply reduce the volume, because once you reduce the volume, you are forcing particles, you are confining particles in a small volume in such a way that these particles will have small space to move in. They will collide with more force, and therefore pressure will increase. If you want to reduce gas pressure, then you increase the area, therefore, or you increase the volume, then gas particles will have more space to move around. They will collide less often and thus reduce gas pressure. Increasing temperature will also increase the atmospheric pressure or gas pressure because particles have more kinetic energy. They will collide with more energy and that increases gas pressure. Then next we move to another topic, that's energy. What we are expected to know about energy, just because of time, we will not cover more on energy, but students should read more on their study guide and other textbook about energy, the forms of energy, the sources of energy, energy conversion. And the main thing that students are advised to know is the law of energy conservation should be stated in fully for one to gain full mark. So the law of energy conservation states that energy cannot be created or destroyed, but it can only be converted from one form to another without any loss in total energy. There are different sources of energy, different forms of energy, as well as energy conservation, energy conversion. Students should read through those. In any case you have an equation, you should feel free and contact the tutor. Then we move to work. Work can be also defined as a product of applied force and the distance moved in the direction of the force. If you can see on the slide, you can see there's F in brackets. That's the correct symbol for force. It should be a capital letter. And then after that, there's this distance moved. In brackets, we have a small letter S. That's the correct symbol for distance. In most cases, students are using a small letter D for distance, but the correct unit, the symbol for distance, is small letter S. For that reason, I'm urging students to use the words instead of using symbols, because in some cases, students are confusing these symbols. So if you are to calculate the work done, the formula is provided there in words. So that's the best way to do, to write it in words, rather than using symbols that you are not familiar with. So work done is equal to force times distance. Force should be in newtons, distance should be in meters. If the distance is given in centimeter, students should convert them to meter. And I hope we all know how to convert. The unit of work done is joules, although after multiplying force by distance you get Newton meter, so the SI unit for work done is joule. The next quantity that we are going to learn is power. Power is defined as the rate of work done, or the rate at which work is done. It can also be defined as the rate at which energy is transferred. At the moment you see the word rate, it means that time is already involved. Therefore, we don't need to include time when you are defining power, as long as the word rate is used. Otherwise, when the word rate is not used, one can define power as work done divided by the time. But at the moment you say it's a rate, it's rather just enough to say power is the rate at which work is done, or energy, or the rate at which energy is transferred. From that definition, one can derive the formula for calculating power, and care should be taken that time should be always converted to seconds. Therefore, the unit for power is watts. 1 watt is 1 joule per second. So that second is from the time quantity that we use. So time should be always in seconds when you are calculating power. At the same time, one can also be given power and time to calculate the work done, or given work done and power to calculate time. So one should be able to use this formula to calculate an unknown quantity. The next topic is transfer of thermal energy. if you might read in some other books, they might write it as thermal physics. The term thermal has to do with heat. That's why there we said 3 types of heat transfer. Heat energy can be transferred in 3 ways. That's by conduction, by convection, and by radiation. Students are expected to know what is meant by conduction, convection, and radiation, and then they should also be able to give an example of application of these 3 transfer of heat energy from everyday life. Conduction is the transfer of heat energy when objects are in contact or in direct contact. For that reason, we are saying metals are the best solid conductors because all their free electrons or all their particles are in touch. So heat can be transferred easily by conduction because in solid particles are in contact, so heat is transferred from one particle to another while the particles are in contact. In liquid particles, we know that the particles are a little bit close, but there are a bit of space in between, so heat might not be transferred fast compared to solid. And then in gas state, particles are far away from each other. Only sometimes when they come in contact, and that's the time when heat will be transferred. That's why gases and liquids are poor conductors of heat by conduction, because they are far away from each other. Only sometimes when they come in contact, that's when heat is transferred by conduction. But heat can be also transferred in liquids and gases by another process, which is now convection. Then you move to the next transfer of energy, that's radiation. Radiation is a way in which heat is transferred from the source to the receiver, and for radiation there is no medium needed to transfer heat. So a heat energy can be transferred through radiation through the vacuum, and therefore there are factors that affect transfer of heat by radiation. For example, the color, the surface. If you are talking of colors, black, dull surface and dark colors, those are good absorber and good emitter of radiation. They can absorb and they can send heat easily. And then the poor radiator or poor absorber are those bright, shine and polished surface, or bright color and shine color. Those are the poor absorber and poor emitter of radiation. Then you move to convection. This is the transfer of heat energy through molecules and atoms, because now, and this involves transfer of heat energy in fluids like liquid and gases, because these particles or the molecules need to move. They absorb heat, then they move the heat, and those cold one comes in. Setup of convection currents. The fluid closer to the heat source expand. Once it receives heat, particles gain energy, then they start moving away from each other. That causes the fluid to expand. When the fluid expands, the density decreases, and then when the density decreases, the fluid will move up. The colder fluid will move closer to the source, absorb heat, expand, and then become less denser and move up again. And that's how convection current works in cooling rooms, in geysers, as well as in electrical kettles. That's why we have one example there, application of convection. Air conditioners are placed near the ceiling because cold air, being denser, will sink to displace warm air in the room. Students should be able to apply the convection, conduction, and radiation, or to apply the transfer of heat energy in everyday life, or to be able to explain how energy is transferred using these 3 methods. Then you move to boiling and evaporation. Students might be asked to differentiate between boiling and evaporation. So these are the points that they can use. Boiling occurs at a fixed temperature, which is called the boiling point, but evaporation will take place or can take place at any time or at any temperature. Boiling takes place or occurs throughout the liquid from the bottom to the surface, but evaporation will only take place on the surface of the liquid. During boiling, the bubbles can be seen or bubbles are visible, but during evaporation, bubbles are not visible. Boiling is a fast process and evaporation is a slow process. For boiling to take place, heat should be supplied by the energy source. For evaporation to take place, heat is absorbed from the surrounding by the substance. There is no need of direct source of energy for evaporation to happen. That's why we know evaporation can take place anytime during the night, when things are drying, when the washed clothes are drying, that's evaporation. It doesn't happen at a specific temperature, it can take place at any temperature. Then you move to the next topic. This is waves. In other books, they either write it as general wave properties. Talking about waves, we start with two main types of waves. There are two main types of waves, transverse wave and longitudinal waves. Students are expected to be able to differentiate between transverse wave and longitudinal waves. Students are expected to be able to give an example of transverse waves and an example of longitudinal waves, depending on the wave's motion. Transverse waves, the movement of particles in the medium is perpendicular to the direction of the wave movement. Transverse waves are the waves that can move either up or down or side by side. The way the particles are moving, they move in such a way that they are perpendicular or 90 degrees to the wave movement. Then longitudinal waves, the movement of particles in a longitudinal waves, it's parallel to the direction of the wave front, of the wave movement. This is an example, example of longitudinal wave, the way they move, there's a to and from motion or back and forth motion. Example of longitudinal waves, we have sound waves and the movement of the spring when it's moved back and forth. That's an example of longitudinal waves. On a longitudinal waves, one can determine the wavelength. We can also be able to label the compression and the rarefaction, which is also called expansion. The wavelength on a longitudinal wave is a distance from one compression to the next compression, or a distance from one expansion to the next expansion. From the transverse wave, students are expected to label different components like a crest, a throw, wavelength, and the amplitude, as well as one complete wave. It was noted that in most cases, students are failing to label the wavelength or the amplitude correctly. Since these are kind of length, as you can see the way the amplitude is labeled, it should be from the crest or from the throat to the resting position, that horizontal line that cuts the wave into an upper and bottom part. The one wavelength should be exactly from the middle of the crest to the middle of the next crest, or from the middle of the throw to the middle of the next throw. One complete wave should have a full upper part and a full down part. Then you move to other properties of waves. We'll start with reflection of light, or rather reflection. If we are to define the reflection in short, it's the bouncing back of the waves. The waves are moving to a certain direction. At a certain point, it reaches an obstacle, then it cannot go through it. Then it will bounce and then go back into another direction. Students are expected to know how to construct reflection diagram and to label the rays and the angles. The incident ray is the incoming ray to the obstacle. The normal line should be drawn perpendicular to the obstacle where the incident ray struck the obstacle. The reflected ray should be drawn such that it bounces when the incident ray bounces back from the surface of reflection. And the two angles that are formed between the reflected ray and the incident rays must be equal. The angle formed between the normal line and the incident ray is called the incident or the angle of incidence, while the angle formed between the normal line and the reflected ray is called the angle of reflection. They are labeled, angle of incidence is labeled with small letter I, the angle of refraction is labeled with small letter R. Then you move to the law of refraction. The law of reflection states that the angle of incidence is equal to the angle of reflection. The incident ray, the reflected ray, and the normal line at the point of incidence all lie on the same plane, unlike in refraction where the normal line might go to the other side. Continuing with reflection of light, students should also be able to construct ray diagram to draw the image formed by the mirror, and therefore they should know these properties. These are general properties of image formed by the plane mirror. The image formed should be upright, it should be virtual. Lateral inverted means that left become right. Same size as the object, should be of the same size as the object, should not be bigger or smaller. The distance from the image to the mirror should be the same as the distance from the object to the mirror. So these are the properties of the image formed by the plane mirror. Then we move to the next property of waves, which is refraction of waves. Reflection of waves is the bending of waves when waves move from one medium into another medium. The reason why the waves bend is because waves travel at different speed in different medium. On the slide, we are provided with reflection of waves from a glass into air. We know a glass is more denser than air. In this case, waves are moving from a denser material into a less denser material. What we can see from the refracted ray is that when the waves move from a glass which is denser than the air, the reflected rays bends away from the normal line. The angle formed, which is now the angle of reflection, it's greater than the angle of incidence. When it comes to reflection, students are also expected to be able to use the formula of calculating the reflective index, where they should also be able to calculate angle of incidence or angle of refraction. But for any question on this, students are expected to contact their tutor. Another aspect of reflection is reflection of light by a triangular prism. When a white light strikes a triangular prism, it will be reflected and it will split into 7 rainbow colors. Students should be able to write the order in which these colors appears. The red followed by orange, yellow, green, blue, indigo, and violet. The diagram should be drawn such that once the white light is reflected, inside the triangular prism, the student should just draw two reflected rays, and then, as well as when they are leaving the triangular prism, only 2 reflected rays, and then they can only just write the name of the colors at the end on the right hand side of the prism. The process by which a white light is reflected by a triangular prism is called dispersion, and the bands of color that is formed, it's called spectrum. So we move to another component of waves, that's sound wave. Sound wave is an example of longitudinal waves. Sound waves are produced during vibrations of particles. Therefore, sound cannot be produced in the vacuum where there are no particles. For sound to be produced, there must be particles. Students are also expected to know how to do the calculation involved in sound. Speed of sound is equal to distance divided by echo time. Echo time is the time taken for a person to hear the echo. If you are to define echo, echo is simple reflected sound. Another component of waves, it's an electromagnetic spectrum. This is an example of transverse wave. Under transverse wave, we have example of light, water waves, and electromagnetic waves. Electromagnetic spectrum or electromagnetic wave, these are waves that travel at the same speed as light. They can travel in the vacuum. They can also travel in other media. Electromagnetic waves do not need a medium to move through. That's why they can also move through the vacuum. They can also absorbed or they can also emitted by different methods. On the next slide, there are uses of different electromagnetic spectrum components. Students are expected to know the order in which this component of the electromagnetic waves appears. They also need to know which one has a shorter wavelength and which one has a high frequency. Starting with radio up to gamma rays, radio has short wavelength. Radio has longer wavelength and a low frequency. Gamma ray has short wavelength and higher frequency. So the frequency increases toward gammas and then it decreases toward radio waves, while the wavelength increases toward radio and decreases toward gamma rays. Several uses of these electromagnetic components can also be found in different books as well as in our study guide. Therefore, students should familiarize themselves with this. We proceed to static electricity. It's the study of the charges that do not flow. These are charges that are produced by rubbing material together. And the charges that are involved during static electricity, these are electrons, because electrons are the only ones that are being transferred, simply because electrons are found on the shells of the atoms. Moving to electricity, we have potential difference, shortened as PD. Is the potential difference across the circuit component. It's the work done to drive a unit charge through the circuits. That's how you define potential difference. Another name for potential difference is voltage. Voltage is measured with the voltmeter, which is always connected across the components. Another component that we need to know on electricity is resistance. It's defined as the ability of the conductor to oppose the flow of charges. Another component we should know under electricity is electric current, defined as the rate at which electric current or electric charge flow past a point on an electric circuit. From this definition, one can derive the formula for calculating electric current given the charge and time. Electric current is also related to voltage and resistance by the formula. Electric current is equal to voltage over resistance. The same formula can also be used to calculate voltage given current and resistance, or to calculate resistance given voltage and current. About electric current, we should know the formula for the instrument that is used to measure electric current. Is an ammeter. On the slide there, that's the circuit symbol of an instrument that can be used to measure current, and that's how it's supposed to be connected. Another diagram, it's a voltmeter, which is used to measure potential difference. Should be connected across a component. On the next slide, it's simple, the diagram that shows series and parallel circuits, how currents and voltage as well as resistance can be determined on two different connections. Students should familiarize themselves with how current, voltage, and resistance can be calculated on a series circuit as well as on the parallel circuits. Apart from that, students are also advised to know the law of the Ohm's law. Ohm's law states that current flowing through a conductor is directly proportional to potential difference, provided that the temperature is constant. In addition to that, students should also be able to identify a graph of an ohmic conductor from that of a non-ohmic conductor. And then they should also be able to provide example of ohmic and non-ohmic conductors. The next topic is hazard of using electricity. This just summarizes what are the dangers of using electricity and how should we use it. I know most of us, we are exposed to electricity, we know how should we use it, but these are just some of the notes on how to take care of electricity. They are listed as such. Coming to magnets, the diagram on the slide shows how magnetic dipoles or magnetic molecules are arranged in a magnetic materials. The law of magnetism is stated there, that the magnet should have north pole and south pole. Induced magnetism is simple producing magnetism on a magnetic material by bringing a magnetic on a magnetic field. The law of magnetism continue. Magnetization using electricity, we can produce magnetism from electricity. All we need is just the battery, the conducting wire, and the soft iron material, or can also be steel. Once current start flowing, we know the rule that says the current conducting wire produces magnetic field. That magnetic field is the one that ionizes, the one that magnetizes the steel bar, and then you start behaving like a magnet. This is just a continuation of what happened when producing magnetism from electricity. The table summarizes the difference between a permanent and an electromagnet. The diagram shows electromagnetic induction, which is applicable in transformer. We have two types of transformers, step-up and step-down transformers. This is a step-down transformer, and there it's a step-down transformer. Students should know the formula, the equation for the transformer that can be used to determine the current, the voltage, and the number of turns. The last topic on our presentation is radioactive decay. Students should know how to define the terminology involved, like radioactive decay, half-life. The most challenging part is how to determine the half-life from a decay curve. The decay curve on the slide shows how one can determine the half-life from the decay curve. So from that decay curve, one can see that the initial amount half from time to time until it reaches a certain amount, and the time taken for it to half from initial amount to half that amount is what we call half-life. With this, we come to an end of our presentation. Again, I will advise you that before the exam, student, we can organize to meet face-to-face so that we can discuss some issue regarding our subject, and this should be done 3 or 2 weeks in advance before the exam. I thank you and I wish you all the best in your study.